Hello, welcome back. We are going to go through titrations and pH curves today. So let's just go ahead and start with what an acid-base titration is. This is using a known concentration to find an unknown. And most of the time it's concentration. Sometimes we will be looking for milliliters, but for the most part, we're finding an unknown concentration. Remember, our acid-base reactions are an acid plus a base gives us water plus a salt. All right. And remember that salt is not always NaCl. All right. We have used some indicators in class already. All right. We have use some indicators in class, and an indicator is a a weak conjugate acid and its base. Let's try that again. Let's say, how about it's a weak acid and its conjugate base. All right. Or it's a weak base and its conjugate acid. And what happens there is they are different colors. So each of these are a different color than the other one. And so when we reach a majority, all right, they'll flip colors. And so then we know when a pH change has occurred. And usually it's a great pH change. We'll kind of see that in a couple of seconds. And our equivalence point is where the moles of the acid equal moles of base. So this is what we're looking for in most cases. Sometimes you'll do like a half titration and so on, but we'll figure that out kind of on down the road. All right, so our titration curve examples, this is kind of what we're looking at. This is what we're spending the bulk of our time with here. If you see this first one, we have a strong acid, strong base. Look at where the pH starts. It starts at 2 and we end at a little over 12. So what we can see here is we can find our equivalence point using this graph here. Where it makes the greatest jump right there is our equivalence point. So 7. And this is usually like 1 drop or something like that. Okay. Now, if we kind of work around the here, we have a strong acid and a weak base. Notice our difference in our ending point of our base. See, this is around 10. So our equivalence point here is less than 7. All right. Then we have a weak acid, weak base. We could jump over there. This one's a little more difficult to find out because right there and there, right? And so this one looks like it's at 7, but it actually relies on the Kas. It's pretty messy. Ka and Kbs of the acid and base. If they're both weak, we look at those and that'll kind of tell us closer to where the equivalence point is. And our last one is a weak acid, strong base. Notice how our pH at the equivalence point is above 7. All right, so that'll tell us kind of what we got going. So these have all been monoprotic acids. Let's look at a polyprotic acid for just a couple of seconds. And we have a couple of things going on here. So first, this is what's happening. We're peeling our H's off one at a time. All right, and so we get this, all right? And then it has like a second reaction happening, and we get this. This is called a successive ionization. All right. And what's happening there is we just keep peeling off the H's. So this is actually a diprotic acid because it has 2 H pluses. And so it's going to have 2 equivalence points. All right. And we can see that there. All right. And we could use 2 separate indicators to see where our color changes. And this is kind of how they change. Like thymol blue starts yellow and then goes to blue. Phenolphthalein, we know, starts clear and goes to pink. All right. Along the same lines, if we're trying to find pKa, all we have to do is find our halfway point to the equivalence point. So when we're halfway to the equivalence point, kind of looking back up here, let's change colors a little bit. Right in there, maybe, that's going to be our pKa. So we can do that. Once we know our halfway point, we can find our pKa because that's our, yeah. All right. Then let's go to endpoint. This is where the reaction stops, right? Reaction stops. And this can be used for a couple of different things. You could talk about it being like that's our equivalence point, so that's where we stop, depending if you're using like uh phenolphthalein or like using an indicator or not, or you could go like a couple of different ways. So endpoint kind of has a couple of different meanings. All right. Most of the time we're looking for it with an indicator. And so like when phenolphthalein turns that light pink, that's when that's our endpoint. So we stop, but sometimes we keep, then there's other times where we keep going and we use the graph. So it's kind of a couple different things. Remember, phenolphthalein is clear at like less than 8 and pink at greater than 8. All right. There's also a whole list on page 817 of a whole bunch of others. All right. See you next time.